Hey guys, my name is Alex. I have a new workflow for you today. This one's called the Infinite Mask Dilation workflow. So I'm going to split this workflow guide into two parts. One is a quick start guide. So if you haven't used my workflows before, I'm just going to run through all of the standard sections that I've set up. So, your input, your prompt, how to configure the models, AnimateDiff, IP adapters, Controlnet, all of that. So if you've used my workflows before, you'll notice that all of these sections are pretty much the same. And if you have used my workflows before, then I'll have the second part of this guide, which talks about the new stuff that I've added. So particularly, the dilation masks, the new audio reactive Dilate Mask Infinite, also the custom schedule node, so you can, trigger mask dilations manually. And then I'll also walk through this new latent noise mask section that I added to the workflow. So without further ado, let's get into the quick start guide. All right, so first things first, if you just want to get up and running with this workflow as quickly as possible, I have some helpful resources here for you. So I've created a workflow guide. So if you go and click on that link, you'll come to this Notion document here where I've listed out all the different sections of the workflow, how all the individual sections should be set up, configured. It's all organized here. So go take a look here if you get stuck at a section later. Otherwise, I have this video here, so I'll leave a link to this video in the workflow. I also have a workflows guide GPT that I created. So here, if you click on that link, you'll come to this custom GPT. I uploaded all of the guide information for my workflow guides here, so you can just ask, specific questions about this infinite mask dilation workflow or any particular custom nodes in this workflow. You'll see that I also included a custom nodes guide GPT link here, so you can also come to this custom nodes guide. So all my custom nodes I have written guides for. If you go to my Notion documents, and then you go up here to this little navigation bar and then click on guides, you'll see this is kind of like the overview page for all of my workflow guides as well as all of my custom node guides. So if in one of my workflows there's this particular custom node that I've created and you want to learn more about it, you can come to the guide here, you can click on it, in this case for Dilate Mask Linear Infinite. You can see how to set up a schedule with the format. You can, see all the different parameters for the node. You can see some examples, why would you want to use it, so on and so forth. So all the information for all my custom nodes, I've again uploaded to the custom nodes guide GPT. So I would first try and ask this GPT some questions, and if you still can't get a good enough answer, then check out the guide for that node. All right, so I'm just going to do a quick run through of all the different sections here and the important ones, which you'll need to configure correctly if you want to get up and running with this workflow. So first, you've got your input section here. So here's where you've got your width and your height of the output video. Every nth, so this is which frames to use. So if it's set to 1, it'll use every frame of the video. If you set to 2, it'll use every other frame. Then down here, you've got skip frames. So this basically tells the workflow, how many frames do you want to skip from the input video. So if I set this, to like 100, then we're going to start at the 100th frame of the video versus set to 0, then it's starting at the very beginning. And you've also got your frame load cap. So this is just how many total frames to load from the video. So in this case, I have it set to 60. So if you're first just trying to get set up with this workflow and you don't want to render out the entire video, you can just set a low frame load cap to maybe 30 or 60 frames, and that'll just let you make sure all your masks are set up correctly, make sure everything is running before you go ahead and set this to 0 and render out your entire video, or set it to some higher number and just render it that way. So moving on, over here you've got your segment dancer section. So this will basically use Sam2 and Florence to try and create a mask of your subject. So if, in this case, I have a dancer, this node will basically just try and grab the mask for that person. If you already have created a mask for your subject, so let's say you have, a red mask for your dancer, and then you have a green mask for some other object in the scene, then you can just bypass this group and then unbypass this upload subject mask group, upload your already rendered mask video, and then from now on, whenever you run the workflow, it'll just pull from this mask instead of trying to regenerate the mask every time. So now we move on to the prompt. So here you've got your positive batch prompt, and you can basically use batching to specify what prompt you want at what point in the video using this format. So you quotes and then your frame number. So in this case, I'm saying frame 0. So basically start from the beginning of the video, and then a colon, and then another quote, and then your prompt, and then close quote. And then you can end with a comma or not, it doesn't matter. But in this case, if I wanted to have another prompt at, frame 100, I could say, whatever I want here, and then the prompt will basically change over the course of the video. So I can target different sections with different prompts and get interesting effects that way. Down here, we have our negative prompt. So you can't really use the batching format for this particular prompt, but you can just say, what are all the things you don't want to see in your final output video. Moving on, you've got some utility functions here. I wouldn't really worry about this section too much. You've got your subject masks. Again, don't really need to mess with this stuff. Down here, we have our model section. So you've got your VAE, and then you've got this model merge stack. So this is basically where you're going to input your checkpoint. So in this case right now, I've actually got two different checkpoints that I'm using. One is sort of a style model, so I'm using the absolute reality LCM. And then one is a model that's better for creating fluid animations. So that's the paradigm LCM. So, you can mix and match checkpoints. So if you have a checkpoint that's really good at a particular style, you can use some percentage of that model mixed with another model that's maybe better at creating good animations. So this is just something you're gonna have to experiment with. This is, the absolute reality and paradigm at these ratios is something that I've found works pretty well for the kind of videos that I make. So again, just play with that. You can always turn these switches on and off here if you want to disable the merging for other checkpoints in the stack. Down here, you've got your LoRa stack, so you can enable switches for multiple, one or more LoRas if you'd like. So right now I have this Animate LCM T2V LoRa at a low weight, and that just kind of helps to improve the animation quality. So again, you can leave this on, you can turn it off. If you have more LoRas you want to add, this is where you do it. Now we have our AnimateDiff section. So starting from the top here, you can upload a AnimateDiff motion LoRa. So in this case, I'm using the Liquid AF model, which adds this kind of smoothing effect to the final output. You can choose the strength here. Moving down, you've got your effect and scale inputs. So if you increase the effect and scale, you'll get more motion in the final output. If you decrease it, you'll get less movement. Then you have your custom CFG. So if you notice that you're not getting enough detail in the final output, try increasing this to 2.5. If you notice the result looks a little overbaked, then maybe try lowering the CFG here. And for the most part here, just make sure you have the right model. So I have Animate LCM SD15 T2V checkpoint. As long as you've got the right model set up here, you shouldn't really need to mess with any of these other settings. So moving on, now we get to our IP adapters. So you'll see that each IP adapter group is set to target a specific mask color. So I have the red group here targeting my red subject mask. Then, green targets green, blue targets blue, black, white, yellow, magenta, and cyan. So the one interesting thing that you'll note is that the yellow and the magenta IP adapters are actually set up to use my new IP adapter custom weights node. And the special thing about this is it lets you essentially transition or crossfade between multiple images. So instead of just having one IP adapter image that will apply to the entire rendering, you can actually transition between multiple images for that particular mask. So it's super cool. You can have all kinds of cool effects that you can pull off with this. So, there's this format that you'll have to learn about. It's basically, the weight, the frame number, how many frames to transition over. So, you can read my custom node guide again to figure out how to set this up. If you don't want to spend the time learning how to, write a schedule for all your inputs, and you just want a basic schedule that says, every 50 frames, let's say, transition between, my images, then what you can do is I actually created a LLM utils workflow. So I'm going to be including this workflow on my Patreon page for free. So if you'd like to use it to help you create some schedules for my custom nodes, go ahead and download that. I've got some setup guide instructions here. Otherwise, so, basically you've got your different workflow sections here. So this is for custom weights. This is for our dilation mask schedule, which I'll talk about later in this video. And then, I just put the node that it's targeting above each group. So it's obvious what each of these LLMs is set up for. So here's a good example. So in my input prompt, I just say, make me a schedule to transition between images every 50 frames, starting at frame 0 and ending at frame 200. And then if you run this, it will take about 4 gigabytes of VRAM. And after a little bit of processing, then it'll spit out a string that looks like this. And that's basically what I asked for. It's saying at frame 0, start at 0, then frame 50, transition to weight of 1, 100, 150, 200. And by default, it'll use 30 frames to define the, the transition time. But you could also specify, make it transition over 60 frames or 90 frames or less, depending on the effect that you want. So just a useful little utility that you can use if you'd like. Okay, going back to the workflow. So that is the IP adapter section. Just make sure you've set up images for all the references for the masks that you want to use. Just keep in mind that if you're running into VRAM issues, then I would try and reduce the number of IP adapters that you're using, because each IP adapter takes up a significant amount of VRAM. So for example, if you're using this yellow and magenta custom weights IP adapters and you start running out of VRAM, then each one of these masks will take 2 IP adapters. So maybe try disabling them and setting your mask to black and white and using these IP adapters instead. So that'll save you some VRAM. So just something to keep in mind. Next, we have our control nets. So here, you're probably going to want to adjust some of the settings depending on the output result you are shooting for. So the AD control net basically just helps with the consistency, also helps to really differentiate between the mask areas, so you get like a sharper line between the different transitions. Same thing with line art. So I like to increase the strength on line art, and also you can increase the end percentage to have the effect be sharper, or you can lower it if you don't want the effect to be as sharp. But in my case, I wanted there to be more of a distinct, edge to the mask. So I increased the strength and end percent on that one. QR code, I would experiment with it. I found in some cases that it sort of washed out the image, and I got better results when I bypassed it. But in some cases, it can be useful, and it can really enhance the final result. So definitely experiment with that one. Depth, I also really like having a stronger effect of depth with this Controlnet, because you'll see here in this output here, you can see, like, you know, there's a tree in the background, and there's like a fence in the backyard, and this floor here. So that helps to add a little bit of consistency to the output and makes use of some of the elements in the original input video. So definitely increase that if you want the output to stay closer to the actual, you know, input background, or lower it if you want, you know, the diffusion to really be a lot more creative with how it, you know, renders things. And lastly, we have open pose. So this is just required if you have a character. So if you're trying to replace your dancer with some diffused character model or reference image, then you definitely want to have open pose, because that'll add a lot more consistency to the, you know, the human movements of that character. All right, and moving down here, we have all of our preprocessor generation groups. So, you know, you've got your line art, depth, anything, and open pose. So if you're, you know, putting in your input video for the first time and hitting run, each one of these groups is going to generate the various preprocessed videos. If you've already generated the preprocessed input videos for your entire video, let's say, you can just, you know, download, save these videos, go ahead and bypass the generation groups, and then you can unbypass these upload groups here. You know, upload the respective video for the different, you know, line art, depth, and open pose, and then every time you run from now on, instead of regenerating, reprocessing your input video, it's just going to pull from your uploaded pre-rendered videos here. All right. So finally, we get to our samplers. So I recommend when you're first running this, you bypass the initial sampler group, and this just lets you make sure that all of your masks and everything is hooked up correctly and running. And then once you're ready to do a test render, maybe just, you know, set a frame load cap of 30 or 60, unbypass this group, you know, queue up, run, make sure that it outputs, everything looks correct here. And then, you know, maybe then you'll do your full render, increase the frame load cap. And then once you've generated with this sampler, you can go ahead and unbypass the second sampler group here. And this will just upscale the results slightly, add a little bit more detail. And that can be really nice to use and later refine in another, you know, upscaler pass or something like Topaz. So that's my recommendation for the sampler. So that is the essentials for sections that you have to configure. And now I'm going to go into the new stuff I added for this workflow that you will want to configure if you're trying to get, you know, the mask dilation set up. All right, so moving on to the new stuff. So up here on the top left side of the workflow, you'll see this audio processing group. So basically what this is going to do is take your input audio from your input video, and then it's going to run it through this audio separation node, which will basically segment it into bass, drums, other, and vocals. You can go down here and you can actually listen to each of the sections and get an idea of how well the separation worked. Then once we've separated the audio into its various stems, we go ahead and process each section separately. And what this does is it allows you to basically clamp the amplitude and also make sure that we're syncing all of the audio to each of the frames. And this is going to help us when we actually want to use the audio to trigger some mask dilations. So you can see basically we've got in this first section our audio bass coming in from the stem. We run it through a frame sync, which basically just maps the amplitude to our input frames. Then we have a binary amplitude gate. And so if you look down here at these two graphs, what you'll see on the first one is normalized amplitude, after frame syncing. So right now we've set the frame load cap to 60, so we're only processing 60 frames. And you'll see, basically over time, these are the spikes in amplitude that correlate to the bass notes. And in your case, you might only want to, let's say, take the loudest bass notes as the triggers for your mask dilations. So the lower amplitude you get, the more input you're likely to run into, whereas higher up you're likely only to get the loudest kind of notes. So in that case, you can actually adjust this threshold value on the binary amplitude gate. So in my case, I set it to 0.8. And what this is going to do is every note or every amplitude value that's above 0.8 is going to be included in our output graph. And that's going to be sent to the dilation mask to be used as trigger points for each dilation. So if you want it to be more sensitive, you can lower the threshold value, and then you'll be hitting more of these amplitude values across. Whereas if you want it to be less sensitive and only take the loudest bass notes, you can set it to something higher, like 0.9. And in this case, it would only take this first, second and third peak here. So yeah, so that's how I would adjust the node depending on how you want to set the sensitivity for your particular input music. So let's see, so we have bass, drums, other, and vocals. So moving on to our Dilate Mask section. So this is going to be basically, the core of the workflow. This is what's actually creating those expanding aura waves off of your subject, or, whatever mask you want to have, these mask dilations occur off of. So if you go to this first node group here, you'll see it's audio reactive dilation. So we're setting up the mask that we want to use to have the dilations. So this will be like the base mask that the dilations occur off of. So in this case, I'm using the subject mask red input mask. And if I had it, if I uploaded a mask video that didn't just have the red subject dancer, but maybe had two dancers, so one was red, one was green, or I have some other object in the scene that's like green or blue, then I can actually target those masks as well. If I go to, this getter node and I scroll all the way down here, you can see you have subject mask red, but then you also have subject mask green and subject mask blue. So if I wanted to target that green dancer instead of the red dancer, then I would click here and I would change that subject mask. Since in this video I only have one dancer, I'm going to leave it on subject mask red. Then the next node here, this next getter, is actually which audio stem to use as the trigger. So in my case, I have it set to audio sync drums. So if we go over here, you'll see that this is processing the drums audio stem. And this is the final output graph, or the final result that's being sent to the mask dilation node to be used as trigger points. So I use the drums because it offers like a really steady beat. It's good for triggering on the beats of the song. So you can adjust this. If you go down, make sure to use one of the audio sync inputs as your input, otherwise it will not work because the sync has been already synced to the audio. So you can come down here, choose sync bass, sync drums, other, or vocals, one of these four. But for my case, I'll just leave it at drums. And then moving on to the actual node itself. So this is the audio reactive dilate mask infinite node. So I'll just do a little run through on how this works. So the first section you have here is a color schedule. So this is basically a set of colors that you want your masks to generate with. So first, this is the format of RGB inside of a parenthesis group, and each RGB value can range from 0 to 255. 0 is the pixel is completely dark, and 255 is it's fully on. In this case, I'm saying I want red to full and blue to full, which will give you a magenta color. And the next color, and make sure you separate the colors with the comma. The next color is going to be red full, green full, blue 0, and this is yellow. So I'm basically saying here, use magenta and then yellow. And what this node will do is every time it triggers a new mask dilation, it will walk through this list of colors. So first it will use magenta, then it will use yellow, and then since there's no more colors, it'll wrap back around and start over. So it'll do magenta, yellow, so on and so forth. If we go down to some of these parameters here, so first we have our threshold. And so this is just setting the threshold for, what amplitude values we're going to trigger our mask dilations from. You can get an idea of what that looks like going back, to here. So I've set the threshold at 0.8, and this is basically going to trigger every time we have an amplitude value that is above that threshold value. Then we get to dilation speed. So this is how quickly the mask is going to expand. So this is saying 25 pixels per frame is how quickly the mask should dilate and expand. Then we have our quality factor. And so this is basically how smooth and how accurate the mask dilation should be to the original shape. So in this case, how accurate it should be to the dancer. And the higher the quality factor, the smoother and the more fluid the dilations are going to be, but it's going to take a lot longer to compute. Whereas if you lower the quality factor to, 0.15 or lower to like 0, for example, you're going to get a lot rougher looking shapes, or maybe, blockier shapes, but it'll be really, really fast to compute. So I like to keep this around 0.15. I think it's a really good balance between speed and quality. But if you're first, using this node and you just want to get a really quick reference on whether or not your masks are dilating at the appropriate times, and if your colors are set up, I would set this to 0 at first, make sure everything looks good, and then bump it up to 0.15 when you're ready to do your final rendering. So next we have should composite subject. So this is just saying, a Boolean value, true or false, whether or not we should put the original mask, the original subject mask, over our mask dilations. So I set this to true, so you can see, we have our red subject dancer in the final composite, but I could also turn this to false, and then, the dancer wouldn't show up. Under here, you have your subject mask color. So if you do set this to true, this is going to be the color of that composited subject mask. In this case, it's red. Then you can also set your initial background color. So right now I have this set to 255, which is yellow. So I'm saying basically start at yellow, then trigger and change the mask color to magenta, then back to yellow, and so on and so forth. Finally, you've got your start frame and end frame. So this just says, if I set the start frame to 80, let's say, then I won't be triggering any mask dilations until after frame 80 is passed. Otherwise, if you set this to 0, it's just saying start at the beginning of the video. And then end frame, if you use 0, that's basically the same as infinite. So it will just trigger mask dilations for the whole entire video. Otherwise, I could set this to something like 100, and then any frames after frame 100 will trigger any more mask dilations. So that is the audio reactive Dilate Mask Infinite node. So this should work if you're trying to have masks dilate based on audio, like, based on the drums or the beat. But if you want to have more control over exactly when these masks dilate, you can use this other, you can bypass the first group and then unbypass the second group here. So this is the custom dilation schedule group. Again, you can set your subject mask. So I'm setting it to the, dancer mask, which is the red subject mask. And then you'll see this node here, and you'll see that there's another sort of string schedule format. And really quickly, what this is doing is, so each one of these parenthesis groups separated by a comma is a new mask that's being triggered. And what the parameters are is, first is the frame index. So in this group, I'm saying, at frame 30, and then the second parameter is the speed of dilation. So I'm saying, expand 15 pixels per frame. And then finally, we have a color for that mask. So in this case, I'm saying 255, which is magenta. I'm saying, this first group in the schedule is saying at frame 30, expand, 15 pixels per frame and use a mask color of magenta. And, then we continue. So then the next time we trigger a mask should be at frame 60, same speed. And then this time use yellow. So I'm alternating magenta, yellow, and so on and so forth for these frames. And this just gives you a lot of control to set exactly when you want these masks dilations to be triggered and exactly at what speed you want them to expand at. So, I could have some of these masks be slower, and then I could have the next mask be faster and like catch up and overlap, the previous expanding mask, and so on and so forth. So again, if you just want to create a simple schedule and you don't want to have to, write out this whole format yourself, you can use my LLM utils workflow that I created. You can come over here to the Dilation Mask Schedule helper, unbypass that, and then you can ask it, to create a simple schedule for you. So in this case, I say, make me a schedule to trigger every 50 frames, starting at frame 0, ending at frame 200, and use the colors red and blue. You'll run this. We'll basically create this string format for you, kind of similar to this one. And then you'll just copy and paste that, slap it back into this node here, and then you'll have your schedule. Moving on, down here you have quality factors. So this is the same as the previous node. Then you have timing mode. So this is basically setting up whether or not to use frame indices, or percentages to decide when to trigger your mask dilation. So if I set it to %, then instead of frame 30, I can say 0.1. So this is saying 10% through the video, I want you to trigger this mask. And then again, I can do 0.25, so then 25% of the way through the video. And so depending on my frame load cap, how many total frames my video is, I can choose exactly what percentage of the way through that video that I want these dilations to occur. So if I have 100 frames, then I'll see all of the different dilations throughout that video, versus if I have a video that's 400 frames, then I'll see it, but it'll be more spaced out. So you can decide to switch between those if you'd like. Then again, down here we have should composite subject, whether or not to use the original subject mask and what color, and then your initial background color. So these are the two major nodes, major groups that are creating this infinite mask dilation effect. Again, if you need more information about how those works, I have custom node guides available. I'll put the link in the description, as well as a custom GPT that you can ask about those nodes and how they work, how to set up schedules. As always, I have an override composite group here, so if you have generated the full video that you'd like, and you don't want to have to keep generating them every time you're changing settings in the workflow, you can save it, upload it here, make sure you bypass the other two groups, and then every time you run, it'll just pull from the video and it won't regenerate. Finally, we have our latent noise mask groups. And so what this is going to do is it's essentially letting you choose what you want to actually have diffused or dreamed over. And what I've done here is basically set up all the different colored masks that are going to be composited in the final video. So we start with this composited mask video over here, and the result is going to be a latent noise mask generated over here. So in this case, for example, I bypassed the red subject mask, and what that's going to do is it's going to remove that mask from the layer, so you get a result like this where everything else is white and then the subject is black. And then when I run a render, it's going to exclude that subject from being diffused, and then it'll basically allow the original input, whatever is behind that mask in the input video, to show up in the final render. So in this case, you can see I have my original dancer video, and then the dancer is showing up in the render, and you can see, you know, I have all the background effects because everything else is set to be diffused. So you can create some interesting effects, some interesting kind of videos using that. But for now, if I set this to enabled, then if I run this, it's going to produce a white mask, and the result is going to be yep, you see that here. The result will be the entire scene will be diffused, including my subject. So yeah, so that is the entire workflow. Again, if you have any questions, I've created this workflows guide GPT. Try and ask you know, any specific questions you have about the workflow. If not, you can always read my Notion guide that I created for this workflow. And if you have any more specific questions for me, you can go, I would recommend joining the Banadoko Discord server. I put a link over here in the workflow credits. So, you know, wherever I posted this workflow, just go ahead and say, you know, I have some issues, can you help me? And I'll try to respond as quickly as I can. Yeah, thank you for watching. If you got something out of this video, make sure to like and subscribe to me. Go check out my GitHub and start the repo if you end up using some of my custom nodes. Otherwise, you can check out my Patreon page. I put the link in the description. I'm going to be putting more exclusive workflows, some early access workflows there over the coming month. So lots of content, lots of value coming out for you guys. If you're already a member and you're supporting me, thank you so much. I will put your name in the outro. So thank you guys. Have a wonderful rest of your day.